Okay, so let's start. Welcome, everybody. My name is Jonathan. I manage some of our AWS management tools like AWS OpsWorks and resource groups. And I'm here to talk to you about how you can use our management tool suite together to manage your applications and resources on AWS. So today I want to give you a brief introduction into what are these management tools, what are their purposes, what is maybe the life cycle that you have to go through when you manage an application and resources. And then I want to dive deep a little bit into some of these and hopefully bring it back with a very practical example of how we can take an example like Java application and manage it completely through this life cycle and take it and build some automated pipelines to completely automate and codify the application through provisioning, monitoring, configuration, and remediation. So let's start with maybe a brief note. If you're interested in these topics, there are 2 sessions on Thursday that you might want to have a look at. So first, there is a session that goes into a little bit more in-depth in terms of building this pipeline, has a nice demo of how you actually create these pipelines. And then we also have a workshop on Thursday afternoon where you can leverage some of the tools that I present here together with the presenters and with some of our engineers to actually get a hands-on example of this and build some of these examples yourself. Now, if I say management tools, what do I mean by that? So if you look at the different services that we offer at AWS, we think of them as different tools that help you to handle the different stages of the application lifecycle or infrastructure management lifecycle, right? So first you need to provision the resources that you need in order to run your application. There we have CloudFormation and Service Catalog that help you with that. Then if we're talking at least instance-based workloads, you need to somehow configure these machines. So configuration management and AWS OpsWorks is something that helps you here. And then you want to monitor these resources and applications. You want to use that feedback loop to drive any necessary changes. And then you also want to be able to act on any of these insights that you got from the monitoring. You want to be able to have audit information. You want to check compliance of these resources, and you want to remediate ultimately, potentially, right? Now, you can see the different tools, and we will have a look at each of them in a minute. The idea here is, and that's a little bit the purpose of my talk, is to show you how you can integrate them and how you can make them interoperable so that when you actually manage your application and your resources, when you start with provisioning, you can kind of maintain the same context throughout this workflow and able to integrate all of these together. Now, so let's have a look at the first one, CloudFormation. How many people here are familiar with CloudFormation and are using CloudFormation already today? So maybe half of the room. So CloudFormation, for those who are not familiar with it, is our main service in order for you to provision resources. And what we mean with provision is to launch them on AWS. As soon as you have kind of a non-trivial use case, right, like you more than just like, let me go to the console and launch something to try it out, I recommend that you have a look at CloudFormation because there you can codify, you can define in a template, right, as infrastructure as code. You can define, here are the resources that I want to have, right? Like, let's say a load balancer, an auto-scaling group with some instances in it, and a database. And CloudFormation then takes this template, this configuration file, if you like, and handles all the provisioning and bootstrapping of these resources for you, and all of the necessary dependencies. Most importantly, it also handles all the various errors that could occur, and if any of them do, it handles the rollback for you. So it's a very robust way of provisioning resources. So let's say you're requesting to run 1,000 EC2 instances, but your account actually only has a limit of another 100, then this state transition will fail, and CloudFormation will do a rollback to revert any other changes that it made necessarily. So CloudFormation is a very core piece of automating the infrastructure and provisioning the necessary resources to run your application on. It supports like a very large number of resource types, over 250. The goal is to ultimately support all of them, right? So that's kind of our core service to provision the resources and allows you to, most importantly, store all of this in code and source control. And we'll have a later look at how we can leverage that to deploy our example application. Now, next is Service Catalog. Service Catalog is probably a little bit less known. It is, if you try to simplify it a bit, an abstraction layer on top of CloudFormation, right? It's the idea that if I take these CloudFormation templates and I build predefined sets of products, how we call them in Service Catalog, where I define already like a standard use case for me. Let's say you're a larger enterprise company and you have like a standard installation of how you like your standard web service and database service to look like. And let's say Apache MySQL, you can define a CloudFormation template that provisions these resources, and then you can make this available in the catalog to your teams so that they can launch this and already use the standard configuration, and then you can centrally update this, and your teams will see that there is a new version of that. It also allows you to restrict access to individual services so that certain organizations have only access to the products and service catalog. So it is a way to define predefined starter kits or applications or products, if you like, that then your teams can leverage. We will use CloudFormation for our example going forward, but this is another way, especially if you have like a large organization where you want to maintain like standard installations. Service Catalog is something worth having a look at. Now, once we launch our instances or our resources, we now need to ensure that the right software is running on them, right? So I need to ensure it's using the right version of, let's say, Apache or Tomcat or Ruby or Java, whatever you want to use. There are in general two ways to achieve this if you simplify, right? Like one way is to have golden AMIs or immutable service where you pre-package everything that you need on an AMI, and then you launch that through CloudFormation or the ASG. The other way, especially if you need more dynamic runtime changes to the configuration, is to use configuration management. In the configuration management space, we have AWS OpsWorks that vents you managed versions of Chef Automate and Puppet Enterprise, the two of the most popular configuration management solutions, where you can get your own Puppet or Chef server that allows you to then define the on-instance configuration, right? You can use the domain-specific language that these tools offer to exactly define basically every bit on the machine, right? Like you can say, I need this particular version of Apache, this particular version of a certain package. This is how exactly I want it to be configured. Let's say you want to always send a certain header with Apache. Like you can define this using a DSL that is much more powerful than if you would write a very long shell script, and it's compatible across operating systems and so forth. OpsWorks in this case is handling all the provisioning and management and operations of the actual Chef or Puppet server. So that means installation, version management, upgrades, backup restores, and integration into the rest of the ecosystem of AWS in terms of CloudTrail and config integration that we will talk about in a second. So OpsWorks is a great solution if you want to be able to control the definition of what is actually running inside a machine. And we'll leverage that in our example to exactly control like the installation of Apache, for example. Now, once I have my infrastructure provisioned, I have the software that I need running on it, I need to monitor it. So CloudWatch is our tool of choice in order to do monitoring in terms of defining metrics, looking at standard metrics that come with a lot of the AWS services in terms of defining my own custom metrics, defining alarms, defining logs. So CloudWatch logs provides you with the ability to stream logs and define log groups, or you can use the CloudWatch agent on EC2 instances to upload, let's say, the Apache log or Tomcat log or any log file that you care about, and then define searches and alerts on these so that define additional metrics. You can also use CloudWatch events to fire off, like let's say Lambda functions or other services. Whenever a certain event is fired, we'll talk about this in a second when we look at config and config rules. And it also allows you to create standard dashboards and graphs for all of these metrics. So that's kind of our standard tool to do resource level monitoring in particular, but also in general to build your operational dashboard, operational console, if you like, if you actually then need to monitor your resources. Another product that we have in the monitoring space is X-Ray. So X-Ray is tailored a lot more towards the application that you're running on AWS, right? So imagine you have a Lambda function or you have your custom web application that uses DynamoDB or it uses S3 or RDS and so forth. And you now want to understand, okay, which calls am I actually doing? How long do they take? And if there are any errors and so forth. So what X-Ray is doing It will take a sample of the requests that are hitting your application and will then trace all of the dependencies, all of the calls to the various dependent AWS services they're using, and will provide you with a service map where you can see, this API call of mine is actually talking to Dynamo, to these 3 Dynamo tables. The calls are taking so long. This call actually fails 10% of the time for certain reasons and so forth. So it's a great tool for you to debug your application, to figure out what's going on, what is the performance characteristics of my application. So that's a very important tool in your application level monitoring, if you like. It kind of comes pre-installed if you use Lambda, and if you use any other application framework, if you like, and then you can integrate it via the SDK, or you can install the agent, the X-Ray agent on your box to push these metrics to the X-Ray service. So with these tools, we now have also an idea how our application is doing in terms of the performance metrics, in terms of the availability metrics, the latency metrics, and so forth. What we don't know yet is if it's compliant with our particular rules and policies that we have in our company, right? So what you can use for that is AWS Config and Config rules. So Config is a service that tracks basically every single change to the resources that Config supports in terms of what are the state changes or attribute changes that happen to them, and what are the values, if you like. So a good example is, let's say you have an EC2 instance. With Config, you're able to tell when did the IP address of that instance change, what was the value before the change and after. Or maybe you're changing the provisioned IOPS of an EBS volume. Those are things that you would be able to trace in Config and Config rules. And then Config will record all of these changes. It will provide you with a history of these changes for every resource. And it will also allow you to define rules on these. And most importantly, it will allow you to dynamically fire events whenever these rules change, in that sense that they're no longer compliant. So to give you a very practical example, let's say you want to ensure that there's no single security group in your account that opens port 80 to the world. So you would be able to define a config rule that says exactly that. And whenever somebody changes a security group, right, like whenever there is an API call that changes the state of the attributes of a security group, this will be recorded by Config. Config will reevaluate the security group, the config rules, and then when now a certain security group is no longer compliant, it will fire a notification that you can then receive with CloudWatch events and then act on it. That means maybe alarm, that means maybe just graph it, or like as we will see in our examples later on, you can also automatically remediate it, right? You might then trigger an automation document that then terminates that instance, or maybe that removes this security group from all the running instances, for example, so that you're also able to automatically respond to it and remediate. The other service that we have in that space is called CloudTrail. CloudTrail is, simply said, a record of all API activity in your account. And it actually also allows you to aggregate this across accounts. So the idea here is every time anything that means somebody in your account, like somebody that is using a role, or also other AWS services that are doing things on your behalf in your account, anytime an API call is made in AWS and in a certain account, this is recorded. And that information includes the caller information, the API call information, the response information, and so forth. And then you can inspect this at any point in time in order to debug or audit or like have some security investigation, right? So you're able to say who terminated that instance last week. That's an information that you would be able to get out of CloudTrail. CloudTrail will also fire CloudWatch events notifications for these things, so that you're also able to define to a sense similar policies like in config rules. So you could, for example, get a notification every time somebody tries to terminate an instance, because that might be something that you don't want to do, that you don't want to allow manually in your team. We say only CloudFormation should be able to terminate instances, so you can get a notification every time a non-CloudFormation actor is trying to do that. And then again, alert on it, just log it or graph it, or maybe even automatically remediate and run a Lambda function or automation document as a response. Now, the last service that I want to give you a high-level overview of is Systems Manager. So Systems Manager has a broad set of capabilities that we will leverage for our example. Let's start with resource groups. So resource groups Technically speaking, it's actually its own service. So resource groups is the glue code that we will use in our example to actually maintain this context as we go from service to service, because it allows you to define, as the name suggests, groups of resources. You can define hierarchy, you can define tag queries that allow you to define what resource should be in this group. And so you can use that to define, here's my production application, here's my staging application, here are the web servers within the production application. And then you will be able to address these groups of resources in other services. So we will use that to, as a target and as a filter in some of our examples later on. Patch Manager allows you to define patch baselines and patch automatically Windows and Linux instances. Allows you to see what are outstanding patches, what are critical patches, and so forth. Run command and automation are probably the two critical capabilities here that allow you to execute scripts, PowerShell scripts, shell scripts inside your EC2 instance or on an on-prem instance. And so this is what run command provides you. You can trigger these based on a schedule. This is essentially what State Manager allows you to do. You can execute them ad hoc, or you can also execute them based on an event. With Session Manager, you can now also get a kind of a live shell into your instance without the need to open any ports or have SSH installed or anything like that. And then automation, this is what we will use for our example later on. Automation allows you to chain executions of run command scripts and interactions with other services to define essentially runbooks or standard operating procedures, right? A good example is here maybe, let's say you have some form of a legacy application that you inherited from another team that is using Tomcat, and for whatever reason, every now and then Tomcat hogs up too much memory and it needs to be restarted. So that will be like something that maybe today you define in a wiki for your on-call engineer to say, if this happens, this is what you need to do. With something like automation, you can actually fully automate that. You could have, let's say you use the CloudWatch agent to monitor the memory consumption of the machine. That creates a CloudWatch alarm whenever the available memory is too low, which fires off a CloudWatch event notification that you can tie onto automation and then execute an automation document that first takes this machine out of the load balancer, using run command actually on the instance itself, restarts Tomcat, and once that is up and running, brings the machine back into the load balancer. So this automation is something you could execute manually, or it's also something that you could fully automate with CloudWatch events to run automatically every time the memory consumption is too high, for example. Maintenance window is the capability that allows you to also execute some of these things like Patch Manager or Run Command automation, as the name suggests, in a certain defined maintenance window where, in contrast to State Manager, it will abort the execution if it takes longer than the defined window. And then inventory is a capability where you can store information collected by the Systems Manager agent from the instance, like let's say the installed packages, the network configuration, the drivers, and so forth, and query them and push them also into config to then execute config rules against. Parameter store allows you to store certain values, key value pairs that you can then reference in the execution of documents, but also uses configuration for your applications. And then last but not least, distribute is a capability we just recently launched that allows you to roll out agents or consume AWS managed agents or your own agents on EC2 instances and on on-prem machines. From these, we will use automation as our example to how you can create this complete remediation, automate that, and also have this automated pipeline. So with this very high-level overview, let's try to make this a little bit more concrete and create what I would call kind of enterprise as code. This is, I think, ultimately what a lot of people want to achieve is how can I fully automate and fully codify my infrastructure, my configuration, my operations, my compliance, and my application delivery, right? That's ultimately the goal that you want to get to. How can I fully create automation for these things so that there is no manual interaction necessary, as long as at least we're speaking about the good path. Obviously, and a human can intervene at any time, but at least for making changes and for storing this, everything is in code, and all of these changes are rolling out completely. That's basically what I want to arrive at the end of this presentation, so that you have an idea of how do I achieve this with the management tools. Now, in order to do this, let me first define what I mean if I talk about application infrastructure and automation and pipelines for these. So when we talk about applications, what I mean here is ultimately the business application you care about. This might be an application you wrote. This is an application maybe you consume from a third party or a vendor, but that's basically the business value, the reason why what you want to run on AWS. And then the underlying infrastructure is what you need in order to actually run it, right? So this is those are the services that you consume from a vendor like Amazon or from others, the EC2 instances, the Lambda functions, the RDS instances, DynamoDB, all of these services that you actually then need in order to run your business application. Now, most of the time, if you want to fully automate this, what you need are two pipelines in order to control this, right? You need kind of one application pipeline that automatically releases and pushes out the changes to your application, and then you need something similar for your infrastructure. And you might argue you might want to also need like a third one for your tools and your operational tools, right? I will focus today mostly on the infrastructure pipeline, but everything applies the same way for the application pipeline. If you look at what is it actually that you need to do there, if we look first at the application pipeline, right, I first need to develop my code, right? Then I need to build it and run tests, like integration tests, unit tests, and so forth. Then I deploy it to my infrastructure, and then I monitor it and see if there are any issues, right, on the application level monitoring, infrastructure level monitoring, and so forth. And ultimately, right, I have my running application, and kind of then the circle starts again anytime I make changes. Pretty much similarly, right, and you will recognize kind of the topics here is what you need to do on an infrastructure level. You need to provision the necessary resources, you need to configure them, then you monitor if everything works accordingly, and you also audit and remediate if necessary, and you do this kind of in a circle. If you want to make this happen today at AWS, you can use a variety of services together, and like I said, mostly I want to focus on how you actually achieve this with the underlying layer for the infrastructure. So the examples I use are AWS services, but you can also imagine using open source or third-party tools here. You can, for most of these examples, you can plug something in that is a third party. Obviously, we want to give you like something that works out of the box, but you can imagine, I don't know, using Jenkins for the build and test part, using obviously a different editor or a different source control repository and so forth. So the standard tools that you could use here for developing application, let's say you use Cloud9 for editing and testing it, you use code commit to actually store your changes and your code repository, and then you use code build to build and test the application and deploy it through code deploy to your infrastructure, and then you use Amazon CloudWatch and X-Ray to monitor any changes and respond to them. For the infrastructure, we will use CloudFormation to provision OpsWorks to do the configuration changes. Then we will use CloudWatch to build dashboards that are tailored to these resources that we just deployed, and then config CloudTrail Systems Manager for the remediation. You notice that I also wrote here resource groups because that's kind of the glue code that, as I said earlier, that connects all of these pieces. So at the end of the day, you can represent the application, you can present the infrastructure as resource groups, and that's what allows you to maintain that context throughout this journey, because you will be able to address the resources and that you provision with CloudFormation later on with through resource groups and the other services. Now, to make this very concrete, because up until this point, this is very, very theoretical, right? Like let's pick a simple example of an application that we want to run here. So let's say we have a very traditional kind of instance-based Java application, right? I think this is a very common stack that you will find. It uses maybe EC2 and a load balancer and an RDS instance to run. You have the code somewhere in Git, and then you want to run like a certain version of Apache, Tomcat, OpenJDK, and so forth. How would you actually make this work with the management tools for the whole deployment story? So the first thing we need is we need to provision the necessary infrastructure, right? So that's what we want to use CloudFormation for, right? So obviously in CloudFormation then I would define these pieces of the infrastructure that I need: the application load balancer, the auto-scaling group that holds up my instances, the RDS database. This is kind of the obvious ones, but you can actually also package in there the other pieces that you need, like the CloudWatch dashboards and alarms, the config rules, the documents that you need. You can actually define the pipelines themselves that we will use later on in the CloudWatch template, in the CloudFormation template. So at the end of the day, you will have a very long template that looks like this, This one here has just a short snippet that defines the auto-scaling group with your load balancer and the instances. But you can find a lot of examples online of how those CloudFormation templates should look like. We also have with the well-architected framework a lot of examples that we vent for standard examples. The important thing here is that all of this is in source control, right? The definition of the infrastructure and the resources I need is in source control. I have it in my Git repository, code commit, GitHub, whatever you want to use. And I can now, every time I want to make a change to it, I can make a code review request to my colleagues. They approve it, and then I push it and promote it. And we will see in a second how this then gets pushed up to the production infrastructure. Now, with this, I actually now have my web servers, my load balancer, my database server running, and so forth. But how do I actually define later on which version of software I need, right? Like that's ultimately what we want to get to the next step. Before we do that, we also need to create the matching resource groups. So I said resource group will be the glue code that will, or the glue object that we will kind of carry forward throughout this journey and use in the other services. So with resource groups, you can define hierarchical groups of resources that you can then address in other services. In this example, I use the CLI, but obviously you can use the SDK and API to do the same thing. So I define a resource group here that proxies, if you like, or kind of acts as a representation of the CloudFormation stack. So in a resource group, you define a query how to find the members. In this example here, we're defining a CloudFormation-based group that looks up the members by saying everything in this group is actually everything that is in this CloudFormation stack over there. All right, and once I have this group, I can now references in the other places. So once we have that, we can now get on with the actual configuration. So how do we get to the actual on-instance configuration? How do we define what we actually need? So for that, we said configuration management. Configuration management might be a good approach. So let's say we pick Chef or Puppet in our example to define the on-instance configuration, right? So we can now define in a fine granular way, how do we actually get Apache 2.4.3.7 running? How do we get a certain version of Tomcat and OpenJDK and all the dependencies that we need? How do we get the necessary users and permissions and everything that you want to have on your machine? You can define that in the Chef cookbook or Puppet or Puppet manifest in this very powerful, very easy to read DSL, where again there is a broad community that publishes standard scripts for a lot of these things, so you don't have to start from scratch. And you have a nice abstraction for doing all of this. So to have a look at an example here, so this is a snippet from the Apache 2 community cookbook that you can find on the Chef supermarket, which is the Chef way to discover and share these open source standard cookbooks that a lot of people use, right? And what I can do here is I can define like my parts of my Apache conf. I can enable SSL. I can define a certain virtual host that runs off a certain template and so forth, right? So even if you're not familiar with the Chef DSL, you get a feeling for, okay, how can I define this on-instance configuration? Obviously, there are other examples for Tomcat and so forth. The important part is, again, this is all code. This is all things that I would have in my Git repository and that my developers or engineers could then make changes to that are in source control, that are traced, that I can roll back and roll forward, and that gets promoted through the pipeline automatically without any manual intervention by me. So once we have that set up, and obviously you need a lot more of these configurations to actually define all the necessary pieces, but hopefully you can find most of them on the supermarket and base your configuration based on these. Then I can go to the next step, right? Like so now we have our instances provisioned, we have them configured with the necessary software that we want to have running on it. Now we want to see how can we actually monitor this. So for that, we're going to use CloudWatch and use a CloudWatch feature that was recently launched, which is the ability to create automated dashboards based on your resource groups. So you might not be able to see that very well, right? But this dropdown here lists the resource groups in my account. So I can select the resource group here, for example, that we created for our matching CloudFormation stack, and CloudWatch will generate automatically dashboards for this. So here's like how the dashboard could look like. where based on the resources that are in this particular group, it will generate the matching graphs and dashboards. So let's say you have a load balancer and a bunch of instances in there, so you will see by default like a graph for the requests per second for the load balancer, the errors, the latency, and so forth. You will see the standard infrastructure host level metrics for your EC2 instances. You will find like IOPS per second consumed or so for EBS volume. So the standard metrics you would expect for all of these resources. Obviously, you can make changes to these. You can create your own dashboards. You can override all of this. But it's a pretty nice kind of default experience that you get for existing resource groups. So that's a very neat feature that allows you, again, to maintain context on that resource group. And you, like I said, you can have hierarchies there. So you could have like a separate one for your front-end web servers and your back-end web servers and whatever you're using for running your particular application. Now, once we did this, we're able already to get like a nice operational dashboard for the infrastructure that I provisioned. The next step is now, how do I actually get some insight with the, in terms of the audit status, of the compliance status of my running infrastructure, right? So this is something we can do with config and config rules. We will look at an example config rule in a second, but what I can do here is if you go to the Systems Manager console, you were able to, here in the Insight section, to also look at resource group scoped violations against your defined config rules, or you can see the CloudTrail events that are only particular for this resource group, right? So that means by default, I'm now able to get a dashboard that tells me here are the non-compliant resources in this resource group. Obviously, again, you can respond to these with automation. You can fire CloudWatch events for all of this, but it's also nice to have like a visual dashboard in the console that will give you some insight into this. So here's an example config rule. We have also an example repository with these. This is also only a snippet of it, but what it does is it essentially, the important line is the last one here that checks if a host, if an EC2 instance is, like in this case, provisioned as a dedicated host or not, right? Like, so for whatever reason, for my team, I created this policy that says all the hosts need to be on dedicated hardware because we don't want to have, we don't want to share it with any other accounts or neighbors. So if you would have that rule defined, you would now be able to see what are all the EC2 instances that don't comply with this policy. Like I said, you can have obviously your own policy. You can look at some of the community policies. I think a good example is the security one that I explained earlier with a security group in port 80. And then once you have these config rules defined, you can now automatically or manually respond to any resources that are not compliant with these. And like I said, you can actually see them then in the dashboard that we looked at earlier. So the next piece is remediation. I want to be able to run any of my runbooks that we were like so automation documents essentially against my resources in a particular resource group. So here I'm looking at the resource group dashboard in the Systems Manager console, and what you can see here on the right is a dropdown that lists me all my automation documents. Right? So I can basically say for this resource group now, let me run a particular automation document that executes whatever logic I want to have in my runbook, right? Like I said, an automation document can either include a run command document, which means it can run inside your instance, or it can run outside of your instance by executing interactions with certain other services. So here's a part of a snippet of an automation document that launches and terminates instances where you define for a certain instance or resource type, what are the desired changes you want to make to certain attributes, and then it's able to execute these for you. A good example, I think, is this Tomcat one that we were talking about, where you need to actually combine changes that are happening outside of the context of an instance, let's say interaction with Elastic or application load balancers or interactions with RDS, let's say, and changes that need to happen inside your instance. That's maybe a good reason to show you where would you want to use an automation document versus a Lambda function. For everything that I say, you could also use Lambdas as the execution for a CloudWatch event, let's say the violation against the config rule. But with automation, you're actually able to run them inside the instance. So another example might be For whatever reason, every now and then your application gets stuck and you need to restart the process. This is not something you could easily do with Lambda because doesn't have access inside your instances, where automation can do that. So you could have a standard automation SOP script that you share with your developers so that they can select it in this list, right? So they no longer need to kind of copy-paste code from the wiki page, but instead they can just look at select for a certain application, essentially, right? A certain resource group. Here's my standard script to re-trigger the restart of my application server, and then you can do this manually, or you can fully automate this again, right? Where you use any CloudWatch event as a trigger for running this for running this automation documents. So with that, right, like we pretty much have the individual pieces of that story covered, right? We have now infrastructure as code through CloudFormation. We have configuration as code through OpsWorks and Puppet or Chef. We have monitoring with CloudWatch that we also can define in code, for example, in the CloudFormation template itself. And then we have automation documents as our SOPs. How do we now tie all of this together and get actually this pipeline going? And how do we actually make it happen that these things are promoted step by step? So this is where code pipeline and code build come in. So code pipeline is a fully managed continuous delivery service by AWS, right? Where I can model this release process and I can define the individual step that I need for my infrastructure pipeline, for my configuration pipeline, for my tools pipeline, right? For basically each of those pieces and make sure that they get applied automatically without any manual intervention. I can define test step and build steps and so forth as the individual steps. So let's say in this example here, we want to deploy an application. So the first thing we have is this step here, which is the source step. So this monitors my Git repository. And every time somebody checks into that Git repository, a transition will happen into the next step. So in this case, a build test step with code build. Like I said, this could also be like a Jenkins step, if you like, or any other custom step, where in this case, the code will be checked out and the test will run on code build. And then if the tests succeed, it will promote to the next step, where in this case, it will be uploaded to S3 so that then the next step could be like deployment with code deploy, for example. Now, this doesn't have to be only your application code, right? Like you could define a very similar pipeline for your configuration code with Chef or Puppet. So, for example, I'm as engineer, I'm making a change to the Apache definition. I want to update the version of Apache that we're using. So I make this change in the Chef cookbook. I commit this change, push it to our Git repository. Code pipeline picks it up, runs any validation or linting that needs to run, and then it uploads it to the Chef server. And then the Chef server distributes it and applies it to all the nodes so that all my instances that are connected to the Chef server will automatically apply this configuration change. This is actually exactly what the sessions on Thursday will walk you through in a lot more details of how you can build this completely with the CloudFormation provisioning, applying the configuration changes, and automating all of this. And you will have a much more hands-on session into these details. So with that, right, I can now automatically promote and release any changes to my application, to my infrastructure, to my to my provisioning of the monitoring, to my remediation scripts that I have with Systems Manager, and you can do the same thing for your config rules, right? So that every time somebody makes changes, these get automatically promoted and released. So that essentially, right, like we now fully automated this creation and this process so that there is no manual interaction necessary, right? So if we think back to this pipeline picture, I now created all of these individual steps and are able to ultimately end up in this world where that we have for infrastructure automation, we have CloudFormation, we have configuration as code through OpsWorks and Chef or Puppet. For operations as code, we use Systems Manager and CloudWatch in my example here. For the compliance pieces, we use config and config rules. And then for the actual application delivery, we use code pipeline and code deploy. And then essentially, there is the glue code around it, which is resource groups and the pipelining, so that I'm able now to make any changes to these pieces in my source control system and have them be automatically released and promoted to my production systems without any human having to verify that. Of course, if I want to, I can add human verifications to this. So I might not be comfortable, like in the very beginning, to have all of this run automatically, like our Tomcat restart examples. Maybe this is not something you want to execute fully automated on all your machines just because memory is low. So you can add, for example, manual approval steps in there. You can also maybe not execute these SOPs automatically, but this is up to you, right? Like the tooling supports all of this so that ultimately you end up in a world where, as a developer, I can make changes in my source control system for my infrastructure pieces that define through CloudFormation what resources do I deploy on AWS, right? Like how many instances do I have, right? Like you can say, let's say you have 4 instances in your application and you want to now change that to 10 because the load increased. So you make a change to your CloudFormation template, you commit that, Code Pipeline will now take this change, push it to CloudFormation. CloudFormation will now update your running infrastructure stack and launch additional servers. If there is a problem, let's say your account doesn't support more instances, it will abort and not promote this change to the next level. But let's say it went through, so now you have 6 additional servers running. These servers will register with, in our example, the chef server through OpsWorks. Will install all the necessary software that you defined, let's say Apache Tomcat and so forth in our example, and will register themselves with the load balancer. The load balancer will verify that they're able to serve traffic normally. Then they will start pushing the metrics to CloudWatch in here, so you will see all of that happening in your dashboards and metrics because they will be part of the resource group, so they will automatically be part of that dashboard that we created. And then because they're now new resources, the config rules will run against these. So I'm able to confirm that all of their configuration is valid with my desired state. And then if you register the ASG with code deploy, they will also be automatically deployed, right? So this is like full automation for all of these pieces without any manual interaction apart from obviously making the code change and committing it. And the same will also be true for any of the other examples, right? Like let's say I change a certain policy in my company where I now want to make sure that certain software is installed or not installed in a certain version. As soon as I commit this and push this, and I have pipelines configured to also update config rules based on these, right? Code pipelines will promote these changes through my infrastructure, and then as soon as it runs against my production environment, I will be able to verify that all of my resources apply now to or are compliant with this new policy, right? So I might, depending on then how you configure the remediation, right? This might only trigger alarms for you, or it will only figure CloudWatch events that you then know. Maybe these just notify you, or maybe these automatically through the integration of CloudWatch events and automation or Lambda act on these violations, like they terminate the resources that are no longer compliant, or they configure them that they cannot be used from the internet, or whatever makes sense for you and your company. You can again fully automate this and fully codify this so that you can verify any changes to that. You can see who did what change and when, and you can roll back all of this. So Code Pipeline will also handle that for you and will not promote any changes to production. Yeah, and with that, my very brief and high-level journey through how you can leverage the management tools comes to an end. And we have a few minutes to go over any questions if you have some. So any questions? Yeah, the slides will be available online. Usually it takes a few days until you can get them from the Session Catalog website, and then all the talks are recorded, so they will be available on YouTube over the next few days. Yes, please.
Do your tools support the concept of a phased rollout? Like I want to roll out my changes to 5% of my...
Yeah, so the question is if the tools support phased rollouts, so you can slowly promote them. So some of these tools support this natively, like let's say code deploy. You can define a velocity. You can do the same with the run command, so you can define only run the script at 5 instances at a time, and when it fails, like stop. You can also reproduce that with Code Pipeline by the way that you define the stages, right? So you can you can either say, okay, one deployment stage or one update stage is my whole CloudFormation stack or all the resources that I have in my account, for example, right? But you can also define units of that where you say, let's say this application target is only a subset of my account, and you define them as individual stages. This is definitely best practice that we recommend. This is how also most teams at Amazon internally roll out software, where we roll it out to what we call a one box, like a single machine in an availability zone. Then we roll it to the whole availability zone, and then we would progress to the next one before we like complete a region, and then we would start like with another single machine in the next region, and so forth. So you can model that with some of the tools. They have this velocity control built in, and with some of the other tools, you need to do this when you define like what is in a resource group or what is my deployment target. You need to define the units that make sense for you. Where like let's say for the staging environment, maybe for the staging environment you're fine deploying it immediately, but for production you probably want to use these smaller increments until you hit the full blown production workload. Any other questions? Yes, please, in the first row. Yeah. So the question was, when we're talking about monitoring, can we also monitor the AWS services themselves? So with CloudWatch, the answer with CloudWatch, no. So CloudWatch only provides with metrics about kind of the built-in metrics that the services report, let's say for EC2, what is the CPU consumption, and then you can define your own metrics. You can get this information through the personal health dashboards in your account that will tell you if there are major events for services that you consume. But through CloudWatch directly, not yet, I believe. I think there was another question over here.
Yes, in a lot of the examples you showed, it uses Puppet and Chef to manage integration.
Yeah.
Grades on the software. Do you also see a lot of people using Ansible as opposed to Puppet and Chef?
So the question was that my examples, I mentioned Puppet and Chef, and if we also see Ansible. The answer is yes, of course. Like everything that I showed you here is also possible with Ansible. I spoke mostly about Chef and Puppet because these are the services for which we have a managed service where you can get your own Chef Automate or Puppet Enterprise server that is managed by AWS. But you can use also Ansible for these examples, right? Like you can have Ansible playbooks that then define the configuration on the instances themselves. And then you trigger these maybe through the user data or maybe through a CloudWatch event and so forth. Or maybe you use Ansible Tower. So at the end of the day, like for most of the pieces that I showed you here, you can replace them with something else, right? Like you can replace CloudFormation with Terraform if that works better for you. You can replace the code build, code pipeline with a tool like Jenkins in that sense, right? Like ultimately you can achieve like an automation pipeline like we were describing with many different tools. It's just that these tools, of course, come built in and they work well together. But at the end of the day, we're very happy for you to use different tools if that fits your workflow better. I think there was another question in the back there, yeah?
Am I correct in assuming that Systems Manager, there is no cost associated with it?
So the question was if Systems Manager has no cost associated with it. This is true for most of Systems Manager. Like we released some features very recently, like the distributor and cross-account automation execution, like and cross-region execution. These actually have a price, but the basic capabilities like run command, automation, patch, and so forth, they're all free. So if you go to the Systems Manager page, the public website, it will list you the pricing. Like I said, it only applies to the distributor use case and cross-account, cross-region execution of automation documents.
Okay,
Yeah.
Supplement if I may. The CloudTrail, one of the biggest pain points for us is the cost is pretty large. Have you come up with any methods by which we can reduce the costs associated?
So the question was that the CloudTrail cost for your use case seems high, and if we're able to lower it. So I cannot speak for the CloudTrail team, but I'm sure that they're looking regularly into how we can reduce costs. So at Amazon, we're very eager to find ways to make all of this cheaper for customers. So we just launched today a feature for S3 where we will automatically put keys that are not being accessed very frequently into like the cheaper, infrequent use storage case. So I'm sure the CloudTrail team is looking into similar improvements, how we can make this cheaper. But the best thing is if you're interested in that is maybe find one of the CloudTrail team members that are running around here today and speak to them. But yeah, like ultimately, yes, like our goal is to make this as cheap as possible because we think like something like CloudTrail is essential to actually have like a proper audit capabilities for your account.
Thank you.
One last question, maybe? Looks like no questions. Oh, here, please.
I really want to display the CloudWatch dashboards on the screen in the command center. I don't want to require someone to log into the console and pull it up. Is there any API access or any other way to pull those up?
So the question is if you can get access to the CloudWatch dashboards also via the CLI or API, or
Yeah, I don't want to make someone log into the console to pull it up on the command center screen.
yeah. So I think today you need to log into the console in order to get access to the actual dashboards. But you have access via API and SDK to the data itself. So you can you can graph this data with other tools. So I think there is a Grafana like open source plugin or so that you can use Grafana to display CloudWatch data, for example. So you can build your own dashboards based on all the data that we saw here, right? Like ultimately, it's just a matter of, how do you display it? What is important is the data itself, which you will get through an API access. Cool, yeah, so thank you very much, everybody, and enjoy the rest of the conference.